Okay, I'm not going to digress to an explanation of why this is the projection. Okay, that explanation's been covered. Go back and review it, read about it, find some other explanation. There are all kinds of them on the internet. But we project the A vector onto the R prime vector. Okay? Now I'm projecting A onto R prime and not onto the unit tangent, but it's the same result either way. Okay, so we could project the A onto the unit tangent vector, project onto this. I'm choosing to project onto the R prime vector, which is our velocity vector. We're going to get the same thing as we would if we projected onto the unit tangent vector. So again, the projection, you just do the dot product of A with R prime divided by the magnitude of R prime. A dot R prime is the component of, well, it's magnitude of A times magnitude of R times cosine theta, where theta is the angle between A and R. And then if you divide by the magnitude of R prime, you're just left with magnitude of A times cosine of theta, with a positive or negative, depending on whether you're in the direction or opposite the direction. I said I wasn't going to digress to that, but I did it quickly. I can't help myself. And we multiply that to get the vector projection by the unit vector in our direction, because this part is just a scalar projection. This part is a unit vector in our direction of motion. And when we multiply the two, we get the parallel component, the parallel component of acceleration, which is the component of the acceleration parallel to our direction of motion, parallel to our line of motion. Okay, could be opposite or in the direction of motion. And we do the calculation, and I'm not going to read the calculation to you. The calculation is very, very straightforward. And you see this 4t squared over pi squared is the same as 4 over pi squared t squared. So you see this denominator here, and you even see this denominator appearing twice, getting squared, and you can think of how this would relate to what you would do if you did the projection of the A vector onto the unit tangent. The numerator is going to be the same, and you're just going to get it. Now, this part of the projection is just the magnitude of R prime, and we have it again because we have R prime over the magnitude of R prime. Okay, so we brought these two R primes together here, magnitude of R prime, but then this is times the R prime. You can think of this as being, again, R prime divided by the magnitude of R prime. And you can see that the magnitude of R prime is just equal to this denominator. So you need to make all these connections and understand how these things interrelate. Okay, now there are two more things to talk about. One is why the derivative of the unit tangent vector is normal, and the other is how in the world do we graph this thing. So we'll come back to that in just a minute.